I want to congratulate all of you for hanging in there. You made it to the last module of the class and you're still showing up. Well done. Um, Today we are going to open up module 18, which is going to be on video game design using Pygame. And I think you probably know I'm excited about this. As I mentioned earlier in the class, wanting to make my own games was what got me into programming in the first place. So I still love playing games. I still love making games, and this unit is no exception to that. I think making games is a fun and creative challenge. So hopefully you'll enjoy this and learn a few things as well. So today we're going to be using a library called Pygame. I would say it's the most popular. It's not the only game library for Python, but Pygame is very, very popular. And you would commonly use Pygame not for making games like Fortnite or any of the modern games that we're playing on consoles these days. What you would really probably use Pygame for are the type of games that I used to play when I was a kid. So games that you might find on, well, maybe an early Nintendo or even an Atari, just like really basic arcade style games. But the nice thing about those is that they're relatively simple, and so that makes them something that we can wrap our mind around even if we're not super advanced programmers. And that's sort of the point of this. So Pygame is really, really, really good for that. Pygame does a lot of things for us, which is kind of nice because it allows us to sort of focus on what we want the game to do and how we want the game to play instead of the really nitty-gritty details of how all of these things work. So it gives us a set of classes to use that represent the structure of the game, the objects in the game, specifically sprites. Sprites, let me talk about it in terms of a game that we all know, like Pac-Man, right? We all know about kind of have a vague notion of how Pac-Man works. Pac-Man, you run around the maze and you eat the little dots and you run away from the ghosts. And if the ghosts turn blue, then you try to eat the ghost. Pac-Man would be a really easy game to make using Pygame. Each of the things on that screen is a sprite. Probably even, if I was going to make Pac-Man, probably even the walls in that maze. Because all of the things that move or interact on a game screen are typically sprites when you're using a construct or a library like Pygame. And the main thing that you want to watch for is collisions between sprites. And given different game conditions, when one sprite touches another, something happens. When Pac-Man touches a little dot, he eats the dot. The dot disappears and you get points. That's what happens in the game logic, right? When Pac-Man touches a ghost, Pac-Man dies unless the ghost is blue. Then the ghost dies and you get points. If Pac-Man eats one of the big dots, then the ghosts turn blue. If Pac-Man bumps into a wall, he doesn't go through the wall. He doesn't go past the wall. He stops. He can't go that direction if there's a wall there. So collisions, which sounds more like a car accident than it's supposed to, collisions between sprites are what make the game, are part of what make a game happen the way it happens. So you have to tell it what happens when this sprite touches this sprite. Does one of them die? Do both die? Is there an explosion? Do you get points? What happens? So that's something big that Pygame does for us that makes things a lot easier. Another thing that it does for us is called screen updates. I'm going to explain more of how that works, but every time something moves on the screen, it's because the screen has updated. You may know this already, but there's no such thing as a moving picture, right? You all know this? There's no such thing as a picture that moves. On your TV, there's a measure called refresh rate. If you're a gamer, you know about refresh rate and how that applies to your gaming situation. But a refresh rate actually refers to how many times per second the picture changes on your TV. And nothing actually moves on your TV. What happens is between this screen and the next one, the objects on the screen change slightly. And if you are watching those in rapid succession, then what happens is the illusion of movement. And it's the same with a game. It's the same with your computer screen. Everything you see that is a moving picture is not actually moving. Yes.
It's almost like a rotary.
A rotary phone?
Film.
Yes. Well, it's like if you look at an old movie, right, and you look at the film, you'll see individual frames. And that's the same thing. Those individual frames are just pictures that are still pictures, each one slightly different than the next, right? And when you play them in succession, it looks like things are moving. Same thing happens in the game. So the screen is always updating, and you can control how fast it updates, which affects how fast things appear to be moving on the screen. And what happens is Pygame will draw each screen and update it for you. And that process does a lot of the work for you to make things easier. So it handles screen updates. It handles controls like the mouse, keyboard, even actual game controllers. Okay? So Pygame can actually connect with a Bluetooth game controller that's connected to your computer, and you can actually map each of the buttons to different things you want to happen in your game. Okay, I didn't bring my game controller with me today, but I'll try to remember it on Wednesday so I can give you a demo of how easy that is actually. It also handles things like sounds, writing on the screen, drawing things on the screen. Lots of things that you can do with Pygame that are quite easy to do.